this review, I would recommend having any of your notes from the unit out just so you can look back and review those as we go through the review. So the first two questions, we're talking about the interior and exterior angles of the following. So as a reminder, to find out the interior angle measure, we have created a little formula. It is going to be n minus 2 multiplied by 180 degrees, and that n is going to be represented of your sides. So if I start on this first shape, I have 1, 2, 3, 4, 5, 6 sides. So if I plug my 6 sides in for my n, 6 minus 2 times 180 degrees, I have 4 times 180 degrees. Giving me an internal sum of 720. I'm going to put a little I here representing the internal sum. And then real easy. When it comes to exterior angles of our polygons, it is always going to be 360 degrees. So it doesn't matter between shape 1 and shape 2. My exterior measure is going to be 360 degrees, no matter the number of sides. So on the second one, let's go through and do the same steps. 2, 3, 4, 5, 6, 7, 8. I'm going to plug 8 in for n. So an 8-sided shape is going to have an interior sum. I'm going to put an I of 1080 degrees. And for the exterior, again, super easy. It is always going to be 360 degrees for these shapes. For this, I'm going to use my n minus 2 times 180 to figure out how many degrees I have in total. I think I then can use that knowledge to solve for x. So I'm going to have 1, 2, 3, 4, 5, 6 sides, which is pretty helpful because I can just look at the equation above. This one also had 6 sides. So I know that a 6-sided shape has to have an interior sum of 720 degrees. That means that all of these sides added up are going to be 720, and I can subtract all of my known angles to get x all by itself. So let me set this up real quick. When I combine together all of my known angles, I am going to get a total of 570 degrees plus x. I'm going to subtract 570 from both sides, leaving me with x is equal to 150. If we look at number 4, I am given measures on the outside of my shape. So if it is on the outside, this is going to be exterior angles. So I know that I'm going to be set equal to 360 because no matter the number of sides, my exterior angle sum is 360 degrees. So I'm going to add up all of my givens. So I've done those. I'm going to simplify this a little bit. I'm going to subtract 200 from both sides, leaving me with 160 is equal to 5x. when I divide both sides by 5, I'm left with x is equal to 32. I apologize on how these papers printed out, but this shape is going to be for 5 and 6, and then this is going to be for 7 through 11. So if I'm looking at this shape, I need to solve for x and solve for y. I know that opposite angles are going to be equivalent. So I can say 2x plus 50. Oops, I'm sorry. They are equivalent, so that means that they are equal. I apologize for setting that up incorrectly. 2x equals 50. Divide both sides by 2. I know that my x is going to be equal to 25. Similar to the angles, my opposite sides are going to be equivalent. So 18 equals y plus 3. I'm just going to subtract 3 from both sides. Y is equal to 5. I just went through and relabeled this parallelogram for you guys. So it should be L, M, and O. P is talking about this side. And then let me see. Q will be equal to this 8.2. Just I had to fill that out because we had some labels missing off our picture. So our first thing is we're going to look at LM. So LM is going to be this side. We are actually going to skip this one. I can't answer what LM is equivalent to because my picture got cut off on my O end. Those are going to be equivalent because they're opposite sides. So we are actually going to skip. Should I? No, actually I would have set it equal to the side. So it's going to be the same measure as ON. LP, this is going to be equivalent to this segment. So our diagonals bisect. So that means that LP must be equal to 7. If we're looking at QM, that is going to be right here. So QM is going to be equal to 8.2. And then this is a typo. This should be measure for angle ONM. So I'm going to start at O, go to N, and go up to M. This is going to be congruent to its opposite angle measure, which is going to be 100 degrees. I do apologize for all the mistakes on here. I would like to preface and say I did not make this review, but I do apologize. We're then going to find angle measure LMN. We're going to use our knowledge about both of these angles being equivalent to 100 degrees and our understanding that a four-sided shape has an interior angle sum of 360. So what I'm going to do for angle LMN is I'm going to have 100 degrees plus 100 degrees plus 2x is equal to 360 degrees. 2x plus 200 is equal to 360. I'm going to subtract 200 from both sides. 2x is equal to 160. X is equal to 80. Let's move on to, this is actually going to be 13 through 15. If I am looking for DCA, that means that I'm looking for this angle measure here. And what I can use here is alternate interior angles. So this angle is going to be congruent to this angle through alternate interior. So if my angle measure is 53 here, that means that this angle measure is also 53 degrees. If I'm looking at DB, that is this whole diagonal, and we know here that our diagonals bisect. So if this segment is 8, that means that this is also 8, meaning that DB in total is 16. I am then looking for A, B, C. So I'm looking at this angle total. There's two pieces of information I can use to help me out here. This angle is being bisected, so I know that this and this are equal to each other. And the second thing that's going to help me out is that my interior angles are going to be 90 degrees. So if I use this triangle, so if I use A, E, B as a triangle, I know that 90 plus 53 plus x is equal to 180 degrees. When I simplify this is 140 degrees plus x equals 180 degrees. If I subtract 143 from both sides, that leaves me with x is equal to 37. But that only gives me this 1/2. So I need to multiply this by 2 to get my angle total. So if I take 37 times 2, that is going to give me an answer of 74 degrees. We are going to skip these two problems because it didn't print out correctly, so we're going to skip these. Moving on to 18, 19, 20, we have a trapezoid. When I have a trapezoid, I like to highlight what my congruent sides are and what my parallel sides are. If I am looking for angle R right here, this is on one parallel line in between the congruent lines, so that means that these two are going to be congruent. So angle R is going to be measured of 82 degrees. If I am then looking for angle T measure, these are two angles on a congruent line in between the parallel lines, so these added together are going to be at 180 degrees. So 82 plus T equals 180 degrees. I'm going to subtract 82 from both sides. That means that this angle measure T is going to be equal to 98 degrees. And then TS is going to be congruent to QR for this last answer. For theorems, you can pull out your proving parallelograms to look at those 5 theorems we have. If we look at this one, I'm given opposite angles are congruent. If we look at this one, opposite sides are congruent. If we look at this third one, this is going to be diagonals bisect. This one, again, we are going to have opposite angles are congruent. For this one, this triangle means parallel. So this is going to be one pair of parallel and congruent sides. For this, I am going to have another diagonals bisect. This one is going to be none. I'm not given one of the 5 theorems. And then lastly, we are going to have both pairs opposite sides parallel.